Today we are going to see the GATE previous year questions on the topic was CPU scheduling. So this question was asked in GATE CS 2022 and it's an MCQ question for 2 marks. So let's deal with this question. So here they are saying that there are 4 processes P, Q, R and S scheduled on a CPU in round robin algorithm with a time quantum of 4 units. So the process arrive in the order PQRS at time 0. So the arrival time of all the processes are given as 0. There is exactly one context switch from S to Q, exactly one context switch from R to Q, and exactly two context switches from Q to R. There is no context switch from S to P. So these are the given conditions. Switching to a ready process after the termination of other process is also considered a context switch. Which one of the following is not possible as CPU burst times in time units of these processes? So they have given the burst times of process PQRS as the 4 options. So we have to choose that which one is not possible CPU burst times for these given conditions. Okay. So here they have given P, Q, R, S, and it's a round robin with time quantum 4. And the arrival time of each process is given as 0. So all the processes arrive at the same time. The burst time of the individual process is given as the option here. So we have to check with these individually, and then they have given the time quantum as 4 units, right? So for round robin algorithm, we know that we have to maintain 2 queues, right? One is a ready queue and the other one is the Gantt chart, right? Fine. So at the arrival time 0, all the process initially will be in the ready queue, right? In the round robin algorithm. So let's take the first option. The burst times are 4, 10, 6, and 2, right? So first the process P will get scheduled for the time quantum of 4 units, right? So from 0 to 4, P will get scheduled. So the remaining burst time will become 0, right? So I'll remove this from the ready queue. And since it's 0, I'll not append it to the end of the queue. Okay. So next we go to the next process. So process Q, right? This is the next process which is in the ready queue. So I'll schedule 4 more time quantum here. So the remaining burst time will be 6, right? And then since it's not 0, I will append it to the end of the queue. Then again, I'll see for the next process, which is R, right? R is the next process. So I'll schedule R for time quantum of 4 units. So the remaining burst time will become 2, right? Since it's not 0, again, I have to remove this and append it to the end. So the next one in the ready queue is S, right? Okay. So in S, the time quantum is 4 units, but the burst time is only 2 units. So I need to schedule only for 2 units, not 4 units, right? So the remaining burst time will become 0 for S. Since it's 0, I can remove it from the queue. Okay. So the next one is Q again, right? So in the ready queue, it's Q. So again, I have to schedule for 4 units of time. So the remaining burst time of Q will become 2. Next, I will schedule. So since it's not 0, right, I have to append it at the end of the queue. Then again, I will schedule R for a time quantum of 2 units, right? So the remaining burst time of R becomes 0. I'll remove it from the queue. Since it becomes 0, I need not append it to the end of the ready queue. Again, the last process, the remaining process is only Q for a time quantum of 2 units, right? So this one becomes 2. So now this one is my Gantt chart. So now I'll see the context switches, whether it matches for the option A, right? So they have given there is exactly one context from S to Q, right? From S to Q, right? So from S to Q, there is one context switch S, and exactly one context switch from R to Q. From R to Q, yeah, from R to Q, there is exactly one quantum switch, and exactly two quantum switches from Q to R. So this is one context switch from Q to R. This is my second context switch from Q to R, right? Yes, this also matches. Then there is no context switch from S to P. From S, it goes only to Q, right? It does not go to P. So there is zero context switch from S to P. Yes, for option A, this condition is satisfied, but they are asking which one is that not possible, right? So we have to check. So option A is possible. So now we are going to check for option B similarly with this procedure. Okay. So again, so I'll rub the burst times. So only the burst times changes, right? All other remains the same. Okay. So again, I'll maintain the ready queue and Gantt chart. Fine. So here now the burst times are 2, 9, 5 and 1, right? So again PQRS will be in the ready queue initially because all arrived at the 0th time interval. So first I'll schedule P for a time quantum of 2 units, right? So it becomes 0. Okay. Next, I'll remove this. I did not append it because it becomes 0. Next, I'll schedule Q for 4 units. So the remaining burst time will become 5. I'll remove it from the queue and it's not 0, right? The burst time has not become 0. So I'll append it here. Then again, I'll see for the next process, which is R. I'll give 4 units for it and the remaining burst time will be 1. I'll remove it from the queue and append it for R. Then I'll see for S. S is for only one time burst time, right? 1 unit of burst time. So I'll give it. Since it becomes 0, I'll just remove it from the ready queue. Then the next one is Q, right? So I'll give it here for 4 time quantum in the Gantt chart. Then the remaining burst time is 1. So it's not 0. So I'll remove it and append it at the end. Then again, I'll do it for the next process, which is R only for one time unit. So it becomes 0, right? So I remove it from the ready queue. That's it. Then the last process is again Q for one time unit. It's 17. Okay. So again, I'll check the condition. That is exactly one context switch from S to Q. S, one context switch from S to Q. Exactly one context switch from R to Q. From R to Q, there is exactly one context switch S and exactly two context switch from Q to R. Q to R, one context switch. Again, Q to R, second context switch. Yes. And there is no context switch from S to P. From S, there is only context switch from Q. So this option also matches. So again, I'll check for the third option. Right. So this one will be my ready queue. And then I'll draw the Gantt chart again. So the burst times here are 4, 12, 5 and 4. So PQRS will be in my ready queue again. So first I will schedule P for a time unit of 4 or time quantum of 4. Since it becomes 0, I'll just remove it from the ready queue. Next, I'll schedule for Q for again 4 units. Then it will become 8, right? So since it's not 0, I'll append it in the ready queue again. Then I'll go to process R and schedule 4 units of time, right? So the remaining burst time will become 1. Since it's not 0 again, I'll append it to the end. Then I'll schedule S for 4 units of time. So now the burst time for S becomes 0. So I'll just remove it from the ready queue. Then again, I'll schedule for Q for 4 units of time. Then the remaining burst time becomes 4 for Q, right? So then I'll append it in the queue again. Next, I'll go for process R. Its burst time, remaining burst time is 1. So I'll schedule 1 unit of time. Since now the burst time becomes 0, I'll just remove it. Then I'll schedule for the last process, which is again Q, right? So the remaining burst time is 4, so I can schedule it. Fine. So now again I'll check the condition from S to Q. There is one context switch. S from R to Q. From R to Q there is one context switch. Again from Q to R there is two context switches. Then from S to P there is no context switch. Again this condition is satisfied. So all these three conditions A, B, C, right? So these are the possible burst times for the round robin technique. So my correct answer will be option D. So but we will cross verify it by checking for option D also. Fine. So, okay. So what are the burst times for P3, 7, 7 and 3, right? So this one will be my ready queue. Next, I'll draw the Gantt chart. So initially it will be 0. My ready queue contains PQRS. So the burst time of P is 3 only, right? So, okay. So I'll just remove it since the burst time becomes 0. So I can schedule 4 units, right? So burst time is now 0 for 3. Okay. Next process we'll go for Q. I'll schedule 4 units of time. So the remaining burst time will become 3. So again, I'll append it to the end. The same procedure is repeated again. Then for R, again 4 units of time. The remaining burst time is 3. Then I'll append it to the end of the ready queue. Then I'll schedule for S for 3 units of time. It becomes 0. So I'll just remove it from the ready queue. Next, I'll append Q for burst time of 3 units. It becomes 0. Next, I'll do for the last process for 3 units of time. It becomes 0. Okay. So now for this, I'll check the condition for the option D, right? From S to Q. There is exactly one context switch S. Okay. From R to Q. So see here. So this condition exactly there is one context switch they have given from R to Q. Whether there is a context switch from R to Q, no, right? So there is no context switch from R to Q, right? This is not there. So these possible burst time will not give a context switch from R to Q. So option D is the right option. Fine.